trying to get them to see the relationship between the partial areas and the total area, instead of asking them to build this exact model.
Yeah, so we decided that keeping it as 13 by 17 is a good idea. Originally, I wanted to let them choose what two numbers they used, but if everyone uses 13 by 17, but they partition it differently, then they can compare their answers, but they can still see this pattern that no matter how they partition it, they still get the same total area. And so we give them the freedom to partition it differently and look for that pattern.
Nice. So they would all add up to 221,
Yeah.
but then they might have just different partial products in the middle.
We kind of like the, to start with that, the given goal and prompt, because that gets them started, and then move on to the same thing, partition it differently, and then even add on like a challenge, like how could you keep the same total area, but partition it so that there's all four areas are the same. You can't do that with a sim, and then we draw the picture and prove your answer.
Oh, okay.
So that they wouldn't be able to use the sim to prove it, but they can kind of play around with things to see that it has to be the same, and then how can you come up with, so it'd have to be halves.
Yeah, so if you just started with 14 and 18, you could use the sim,
Yeah.
right?
Exactly.
Because you're talking about into equal fourths.
Yeah, so if you have...
We like the fact that the sim wouldn't answer that for them.
Oh, okay. Or maybe make one of the numbers even.
Well, they could play around with different things, and then I think the discussions within the partners would be, well, how did you get that answer? What do you think about this? And so, have it 3 layers. Like here's the given one, and then try to find the same area with different dimensions, and then how can you make all four the same? Kind of as a scaffolding or a challenge question.
Yeah, yeah. And something else I heard this group talking about too was taking it to the next step. If you want them to eventually partition, like at 10, or if you're in the decimal sim at the integers, kind of if a student does partition in here, kind of generates that question, well, what's kind of convenient about partitioning in here? They might notice it's a little easier to add up the numbers inside. So if you do have an additional goal of partitioning it in a productive or convenient way, someone in the class might have done that, and we can help lead to that. Anything else? Oh, sorry, what?
I was just thinking the mental math product of 13, like how can we split it up? Even 17 times 10.
I like that extension question of dividing it evenly into fours. We had, where I had asking them to partition it, or the 13 in 2 different ways, and then 17 in 2 different ways, and then choose one for each to do the problem. And then that maybe could lead to what you were talking about, of having a discussion about why they chose which.
The one they did, yeah. Yeah, that makes sense. Yeah, like as long as actually, if any of these, this was 5 and 5, even that is still potentially, well, actually, I don't know. There might be other ways that are easier to add up, I think, than just putting it anywhere.
17 times 10, 17 times 3. And then 17 times 10, 170 is 17.
Right, yeah.
51, and then, yeah, good.
Mm-hmm.